So welcome to the last session. We saved the best for last. This is Markus Schlegel. He is a software architect at Active Group. He is an expert in functional programming, user interface design, and formal methods. And he has combined all his expertise to teach you today about type-driven user interfaces. Enjoy.
Thank you. So this is going to be our mission, our work order for the next 45 minutes or so. We want to design a user interface for an import dialog for some entity of a larger system, doesn't really matter what it is, where a user should be able to load some previously exported file from her computer into the dialog, basically, check whether everything is correct, and then upload that entity to the server. If everything is correct, the server answers with an entity ID. Simple. So you can then use this ID to generate a link to another page that's out of scope, but the user can click this link and be sent off to the next screen. These entity files are either JSON or YAML files, and well, there's some basic validation going on. Now, in the classic, what I call the classic UI design process, you now do something like this. There are basically two stages. You have this mission statement, which we were now provided with, and we want to transform that into a UI design, so some working thing in the end, right? And the tools that we're going to use are stuff like pen and pencil, pen and paper in the early stages, or wireframes, mockups, buttons, text fields, layout, typography, shapes, colors, these kinds of things. And in the end, you end up with something like this. So this is a finished user interface design. As I said, there's going to be buttons and shapes and grids and text fields, all these good things. And one of your stakeholders, one of the people you present this to, is going to go, great, this is exactly what I had in mind. You are a great designer. I love you. But another one is maybe not that pleased. He's going to go, nah, this is not good UI design. This is not what I had in mind. And of course, a little discussion ensues, because why do you think it's bad? What do you think is bad? A little discussion ensues. But in my experience, at least, there's these kinds of discussions that center around a finished design. They're always very superficial. They don't get to the essence, to the core of what people think is wrong, right? Of course, there's also some people always just being utterly confused and not saying anything. This is the worst outcome because you don't even get to know what they think is wrong. And this reminds me a lot of about the classic software design process in general, which is also, you take this mission statement, this work order, which is usually just maybe a 2-hour workshop or a Jira ticket or whatever, and you transform that in sort of one giant leap into an implementation. So that's working software on the right here, working software that's actually running on a computer. And the tools that you use are going to be stuff like design patterns, dry, solid, whatever, agile, of course. Everyone wants to be agile. Classes, methods, algorithms, RPC, and microservices, all the rage. Blockchain, possibly, of course. And in the end, you end up with something like this. There's pipes and nuts and bolts and GraphQL. And again, a stakeholder is going, great, is exactly what I had in mind. You're a genius. Another one, not that pleased, right? And a third one, of course, utterly confused again. And again, these discussions that ensue are very superficial. Nothing, like, you can't really punch through to the core, to the essence of what's actually wrong here. Probably the problem was that there wasn't even a shared understanding to begin with what the finished software should look like. Or what it is supposed to do. And as Markus introduced, as he already told about me, I'm a functional programmer. I'm not like a classic programmer. I'm from the functional tradition, and we sort of identified this problem with the classic approach, and we don't use this approach. We use this two-step approach to functional software design, which is you take this initial statement, mission statement, this initial vague specification, or this 2-hour workshop, and the first thing you do is you produce a mathematical model. So this model, it has nothing to do with software. It has nothing to do with computers even. And only then, only the next step, if you are totally confident in your model with all the stakeholders involved, only then you go on to derive even an implementation from that. Now this model is a formal model. It's a mathematical model based on mathematical languages and grammars, and it has to be precise, adequate, and simple. Precision is sort of given by it being mathematical and formal. In a formal language. Adequate, of course, it has to be, it has to have a relation to the actual problem. And simple, it has to be simple because the stakeholders involved, they probably don't have a lot of time dedicated to your specific project. So it has to be, the communication has to be very dense, and a simple model allows for that. Also, it has to be simple because me as a single human being, I'm basically not very smart. I have to rely on simple math in order to have a further reach with my thoughts. And that's what I'm going to show you, like in more detail now. What does it mean, formal model? Maybe you don't even know what, have no clear picture in mind. And there are many approaches to this. Today I'm going to be basing mine on types, as the title of the talk already suggests. Types, like static types, are research sort of area in functional programming, and specifically. But you already have a vague notion of types already. I think there are many languages like Java. Even they have primitive types, or they have like can you build your own types sort of with classes, and that's what we're gonna do basically in this talk as well. So there are primitive types such as booleans and integers and strings and file handles, for example. But in functional programming, we like to combine things, we like to compose stuff, and we also like to combine or compose types. And so there are many type combinators, and the two I want to focus on today are product types and sum types. Product types, is this working? Oh yeah. Product types are, this is a bit of Haskell, but doesn't really matter. As I said, it's not about working software, it's just about thinking. Still, this is some Haskell code, so you could have something to read on the slide. And this basically just says, we introduce a new type, which is called foo, and it is the product of an A, that's some other type, and a B. And it's also, I already said it, it's an A and a B at the same time. It's both at the same time. This guy is holding up two signs saying, well, I'm here for both of these things. And the jewel to that is sum types. So while you're probably aware of product types already, like you know records, right? You know all like classes can define many fields. The jewel is maybe not that familiar to you. What does that mean? Well, the jewel to AND is OR. So if you define a sum type, a new sum type called foo, and you say it's an A or a B, well, it means exactly that. You either have an A or you have a B. And well, what I forgot to say, my notion of types here is shape of data, right? So these types define some shape of data. So when I say you either have an A or a B, it means you either have a value of an A or you have a value of a B if you have a foo. And with that in mind, we can try to build our first model for our import dialog. And so this is simple enough. We start with sort of the top level type, which is an import, which we call import. So we announce a new type with this Haskellism data import. We sort of have to repeat that word again, doesn't matter for now. And this is a product type, based on 3 other types. This is a file, so that's a primitive file handle, for example, a file type, and an import state. File type I'll omit for now. It's just this YAML or JSON thing. And this import state, in turn, is another user-defined type. And it's the one below, which says it's also a product type. So it's a load error, loaded data, upload error, and an entity ID. These in turn mean other things, but we can work with this for now. And this is fine, this works. Everything that we want to express can be expressed with these definitions, but there is also some states, some combinations, some shapes, or some data can be expressed that we don't want to express necessarily because it doesn't make sense. For example, if we have an error, we probably don't have loaded data, right? If there was an error, that usually means there's nothing there. Or if we have, like, if this is well, if this is null, it has to be null in any way. Like, all of these have to be nullable, sort of. And there's some loaded data. Still doesn't have to mean that we have an upload error. So this also has to be nullable. And it also doesn't mean that we necessarily have an entity ID, because we want to give the user a bit of time to think, right? Maybe we have this loaded data, we want to present it to the user, but there's no upload happened yet, so we don't have an entity ID. So all of these fields have to be nullable, and there are then still combinations that just don't make sense. This is the huge, ugly lightning bolt sort of wants to show that something is wrong here. And the number one principle that we violated here, basically in functional programming, everyone follows these 4 words. It's that we want to make illegal states unrepresentable. And that's what we violated, right? There were states that didn't make any sense. If we have an error, can't have some data, there's these 2 stages. There are some states that are illegal, but still we could represent them. So let's go for second try. And remember, we had these product types, which is a thing you're probably most familiar with, but there's also the sum types, which is the either-or case. So let's use those for now. And well, our top-level type stays the same. It's still it's still a product type based on 3 types. Nothing wrong here. But now the import state is a sum type. And this sum type now basically denotes the 3 cases that we have in our system. One second. Which is, well, there can be a loading state. So if the file handle is just, well, we picked some file, that's only just a handle, but it needs to be loaded from the system. Could take a fairly long while if it's multiple gigabytes. And so we can be in a loading stage where we don't have any additional info at all. If the loading stage is finished, we can end up in either of 2 cases: load failure, where we have an error, or load success, where then finally we have some loaded data. And also, most crucially, in the success case, it now makes sense to talk about the upload. Because it doesn't make sense to talk about the upload if the loading didn't even finish, or if there was an error. But now, if the load succeeded, we can talk about the upload state. And the upload state, in turn, is another sum type. And that's a sum type of 4 cases. There can be a ready state. The user wants to still vet some details about this to be imported file. Then she clicks on some button or something, she progresses to the uploading phase. And when the uploading phase is done, we end up in either of 2 cases. Again, there can be a failure, where we have an error, or there can be a success case. And only now in the upload success case, it makes sense to talk about an entity ID, because only now the server has given us one. Doesn't make sense to have it before we even loaded the file, or while the upload is still running. And now that was the functional software design process, or like the details, some details of that, where we take a mission statement, we produce a model, and then only derive an implementation from that. Now I want to propose today that we can use that for user interface design as well. where I'm calling it the functional user interface design process, or the title says it's the type-driven user interface design process, where we take a mission statement, we produce this model first, which is the thing, like the communication tool number one in functional programming. All of the stakeholders can agree or disagree based on this one model, and only then reproduce a UI design from that. And we'll see shortly how that works. Now, another important aspect that I forgot to mention about this model is maybe you're familiar with the distinction of accidental and essential complexity. Maybe not, but it's really easy to understand. So there's in any system, there's probably a lot of there's a lot of complexity, but some of this complexity is essential. It's like essential to the domain. There's nothing really you can do about it. It's core to your business, right? But there's a lot of complexity that you can get rid of, or that's just concerned with externalities like it has to run on a computer, right? A computer has a certain speed and memory, and there are probably legacy systems that are involved that you have to deal with. And those are not like the core. Those are not core business complexities. Those are just there. You have to deal with them. You want to reduce the accidental complexity as much as possible. But whenever you talk to like a business person or manager, you probably want to talk to them about essential complexity first. And that's what the model is about, right? I said it's not about computers at all. It's only about the essence of things. But now we want to see how, like, we now produce this model and we agreed with our stakeholders, yes, that's what we intended to do. There's this two-phase upload thing, and it doesn't make sense to have an entity ID in any of the stages that denote errors or loading stages or whatever. We agreed on that, but now we want to produce a UI design, right? That's what you're here for. And there are many ways to do this, but I'm just going to go through the example, and you sort of have to derive the rules that are at play here while we go along. So we have this model, which is based on sort of three types that we defined ourselves, or three main types. And we sort of start from the top, so we make a top-down design. So we start with this import state at the top, and it's a product type. We remember it's a file type, and an import state. Product type means we have a file and a file type and an import state. So a UI, user interface, should probably show all these three user interfaces. So a user interface for a file, a user interface for a file type, and a user interface for an import state at the same time. And since there's no clear distinction like which goes before another, we just lay them out as they are for now, top to bottom. The idea in functional programming that's sort of shining through here is often that you build up small things, you build up larger things from small things, and that's what we do here now. We build up a larger user interface from smaller user interfaces, which we don't even know anything particular about. We can just draw these vague boxes for now, right? And now we can sort of refine this design. So basically, we could say that's done, right? And we could show them, could show it to someone, but they will ask further questions, and we can answer them by refining it a bit. So a file, the file type, which denotes a file handle, is probably best represented by a file picker. So whenever you end up at a sort of primitive type in your system, there's probably also a corresponding user interface in the framework you're using already. And in this case, file picker, probably every major user interface UI design framework already has one, has a file picker. Now for the file type, we said it's a JSON or YAML thing. That's user manipulable. It's user manipulable. And it's also a sum type, sort of, right? We have this either JSON or YAML, and whenever it's such a simple sum type, you probably can opt for a radio button group. So the JSON or YAML button group denotes or is a user interface for a sum type of these two elements. Now the next box is represented by this more involved type again, and now this is a sum type. And a sum type, now we saw the product type, which means we have all these constituents at the same time. A sum type means you have them, like you have either of them at any point in time. You only have one of them, one of the cases. So it doesn't make sense to lay them out as we did before, just top to bottom or left to right. Instead, since they're also not directly user defined, manipulable, these are just different stages in our user interface, just different at different times these cases occur. So let's step through them one by one. If we have the loading situation, loading case, well, the best user interface for a loading case where we don't have any further input, further information to show, is to just show a loading spinner. In the load failure case, we probably show this error thing. I'm going to skip that for now. In the load success case, well, we announce first that we're in this load success case, so we show some check mark, well, it succeeded. And in turn, that's a product type again. And again, product types are probably best described by interfaces that show the constituent types sort of at the same time in some layout. So we've laid them out top to bottom again, these data and upload state things. And we dive further in. The data, well, that's another type that we can define ourselves. There's maybe some name and a created date and some picture. Let's not dive too deep into that, but you can just imagine it goes on and on like we did before. And we can display that. And for the upload state, again, that's a more interesting situation. We again have a sum type based on 4 cases. And the ready stage, well, we want to sort of defer further actions by just announcing, well, we're now ready to upload. And the user, this is one of the few cases in this interface where the user can progress to the next stage by an explicit action. And so we show this button, and upon hitting that button, we end up in the uploading phase. Again, uploading, no further info, just announce that we're in this case, we show a spinner. We again skip this failure case and move right on to the upload success case. And well, again, the same story, we just announced the upload succeeded, and now we have this entity ID at our hand that's coming from the server, excuse me, from the server, and so we can show a link. And we do that. There wouldn't even have been any possibility to do that before this point in time, right? So that's our user interface. That's just so. That's why I said we want to derive a user interface, and this is our sort of initial or our initial design that we now derive sort of mechanically. We didn't have to think a lot, right? I certainly didn't think. I just looked at my slides real close. And now maybe you're graphics person and you're aesthetically inclined to work on that, to further refine that. But this basic idea still holds, that there's this model and there's a user interface that corresponds very closely to that. So if you want to deviate from that, from the model, you then have to justify this deviation, I think. And maybe some options are still not captured by the model. For example, I now lay them out sort of vertically. These elements, you could have sometimes chosen to lay them out horizontally, but the basic idea stays the same. And that's also brings me to my conclusion, which is based on these 4 points. I think you should capture your understanding of a problem domain in a model that is adequate, precise, and simple. So it's sort of necessarily a mathematical model, and you should communicate this model with your stakeholders, with non-technical people. We do this all the time, right? Us programmers, we're sometimes afraid to show code or something to other people that might not understand what's going on. But these models, they're explicitly, or you should explicitly design them to show them to other non-technical people, because they're not about computers, they're about thinking precisely. Models also decouple accidental from essential complexity, so sort of, yeah, this all blends into one idea here. And for the first try, I suggest you model your domains with the help of product and sum type combinators. There are other ways, If you are interested, you can talk to me later. And if you have this, there are many ways you can continue. In this instance, I'm talking about user interfaces, so you can mechanically derive user interfaces from your model. You can also sort of almost derive working software in some instances from these models, or other things. Also, again, talk to me if you're more interested in what else you can achieve with modeling. And the next slide is, I don't know, oh, it's the next slide, yes. It says thank you, because this is the end of my talk, and I want to thank you.